Ladies and gentlemen, distinguished guests, good morning. Welcome to the CIC Master Class on AI for Construction kickoff ceremony. This is Janice. It's my great pleasure to be your MC today. Welcome, everyone. Thank you. It is our great honor to have all of you here with us today. Apart from our guests participating here in person, our event is also broadcasting live online and attended by the guests from around the world. A very warm welcome to our online audience as well. Construction Industry Council has been launched a series of signature courses to enhance the industry's capacity to adopt AI and advanced digital solutions for projects in Hong Kong. And now we are going to launch the 5th course, CIC Master Class on Artificial Intelligence, AI for Construction. The course will cover current development of the theoretical and practical aspects of AI in construction industry, and it aims to provide practitioners who wish to leverage digitalization to improve business process through advanced computation and AI. So now the event is officially begins. First of all, I would like to invite Chairman of Construction Industry Council, Engineer Thomas Ho, to come up to the stage for the welcome address. Ladies and gentlemen, please join me in welcoming Engineer Ho.
Dear Lillian, the Honorable Duncan, 李澤湘教授 Dear fellow digital construction supporters and 各位建築人, welcome to today's CIC Master Class on AI for Construction Kick-Off Ceremony. According to the Hong Kong Innovation and Technology Development Blueprint, artificial intelligence is one of the technology industry with an edge in Hong Kong. And Hong Kong has a sound foundation in AI research. Universities in Hong Kong as a whole ranked number 3 in terms of producing the most cited and impactful research on AI in Hong Kong. Hong Kong ITDB proposes to focus on the development of AI and data science. AI is an emerging innovation and it no longer only appears in movies. It is already very mature in fintech, health tech, and prop tech. AI, machine learning, automation, and robotics have been mentioned a lot in our construction industry for the last few years. However, looking closer to our construction site, it seems the application is still very limited. But it had advanced significantly in the last 12 months. And a lot of good examples I will highlight, I think, later. Again, this is time for construction industry to catch up, to think about how to adopt more AI in context. Last week, during the CIC annual cocktail, Secretary for Development had highlighted the 4S 安全智慧工地 will be announced in Q1. The whole idea is to spearhead more contact on site, and it will mean there will be a lot more integrated CDE in our construction industry, then boosting a lot of AI in construction. I'd like to stress AI can be adopted in the whole life cycle of our asset management. In the design stage, with the machine learning, curtain wall elements can be standardized using parametric design to reduce the panel type, making all this much more buildable, and maintenance will get so much easier. In the construction stage, for example, when workers arriving at our construction site, cameras with AI are now actively collecting various information, and those can connect to the cameras at the tower cranes to monitor progress, trade by trade, workers by worker. Take another example. A drone can fly through 5-6 kilometers of the tunnel to monitor the site progress, and while the data analytic can flag up alert KPIs from management to action. I just visited a project in Wan Chai. The project using an autonomous robotic system to do elevator shaft drilling. This improves site safety and health by reducing the time technicians need to spend inside the shaft, being exposed to dust, noise, and repetitive non-ergonomic work, demonstrating how advanced technology can be the best way to deliver the CIC motto, life first, say no to danger. AI can also be adopted in operation and maintenance stage. Building operation and maintenance data were too massive to understand in the past can now be efficiently visualized and analyzed using AI's dashboard. ENSD has been doing this a lot now. Electricity usage in the building can be monitored, such as air conditioning and lift, where electricity is used the most, can also be adjusted automatically now. We have already seen projects that could save electricity by over 50%. I visited the Henderson, the ICC, the Haominggai, all are moving in that direction. This not only helps a great deal in achieving carbon net zero, but also save your wallet as well. There are a lot more, like AI scheduling and risk simulation, AI just-in-time logistics, AI for sustainability. Now, seeing is believing. Watch the video to see what AI can do for the construction industry. We should capitalize on these technologies and adopt more onto our construction life cycle to bring maximum benefits to the industry, enhance safety, sustainability, productivity, and quality. For example, building design option can be used to investigate manually. By using parametric design optimization, numerous design options can be studied that shorten the design period. GFA is used to calculate via CAD manually, but using BIM automation of gross floor area, the automated calculation shortened the time from few weeks to 30 minutes. By using big data and AI machine learning for predictive measure, there is enhancement of energy up to 60%. We can also do automation to generate the wall openings based on the overall dimension of the surfaces penetrating through, and also sizes and places that require lintel can be developed according to the structural requirements. By now, I think you should all be converted to the real power of AI for construction. This master class is very unique. We will involve a world-class leading practitioner academia to introduce the pragmatic science behind innovation, notably 李澤湘教授, the leading AI expert, and mastermind behind Daigang DJI. Professor Martin Fisher, leading construction AI expert from Stanford University, as well as local expert from Hong Kong University, Wilson Lu, Hong Kong UST, Jack Zhang, PolyU, Henley, MIT, Hong Kong Innovation Note, Charles Sunsin. All the experts are here today, and we have commissioned the expert advisory panel and doing an industry survey to ascertain the AI maturity in our local industry, collect various AI applications from the leading practitioners like the Arab, Gammon, MTLC, URA, Shoyon, Yao Li, as well as collect some pain points and wish lists that AI can help in construction activities. This CIC Master Class on AI for construction focuses not only on the aspiration AI could bring to the industry, but also share actual use cases and application from construction experts to disseminate the knowledge and lesson learned. The masterclass will commence with the sharing of the strategic use of AI from an organization viewpoint. Experts will share not only what they have done, but also how to do it and what are the implementation obstacles and how to overcome them. The class will cover AI application throughout the design, planning, project management, construction, operation, and maintenance stages. The CIC Master Class for Construction aims to build and train local personnel in Hong Kong. We plan to organize 4 classes per year, with class of the size at least 30 every year. Then there will be over hundreds of trained personnel developed each year, which we name them as change agents. I hope this change agent can pass on their knowledge and experience and be serving as a catalyst of transformation for the construction industry in Hong Kong. I've asked my course director, Alex, to put in the following challenges to those change agents. And as I said, this smart site safety system, 安全智慧工地, will be implemented. Each site now will have smart items. And I asked my change agent to adopt AI and make sure those are smart items, make them even smarter and more integrated. And then we're able to do the data analytics for online project management. So the 1,400 sites in Hong Kong, if they can really do this transformation, the impact would be huge. To conclude, we must embrace digitization, train up practitioners, and prepare our industry for this golden era to come. 300 billion year by year for the next 10, 15 years. We must create asset, 產業, in the next 10 years to the 5% GDP highlighted in Professor Xun Dong and Lilian sort of blueprint and roadmap. Thank you very much.
Thank you. Thank you very much, Engineer Ho, for the speech. Please be seated. Thank you. As mentioned by Chairman Ho, the CIC Master Class on AI for Construction invited leading AI academia and construction experts to dissemble knowledge and practical exercise and their practical experience. It will definitely help the industry practitioners to adopt AI in the whole project life cycle. And now we would like to invite our guest of honor, the Undersecretary for Innovation, Technology and Industry, Ms. Lilian Chang, to come up to the stage to deliver the opening speech. Let's welcome Ms. Chang.
Dear Chairman Thomas, Duncan, Professor Lee, Albert, distinguished guests, ladies and gentlemen, good morning. Thank you. I'm very pleased to join you all today at the CIC Masterclass on AI for Construction kickoff ceremony. It was just introduced by Thomas. In December last year, the government promulgated the Hong Kong Innovation and Technology Development Blueprint to establish a clear development path and formulate systematic strategic planning for Hong Kong's I&T development over the next 5 to 10 years. Charting Hong Kong in moving full steam towards the vision of an innovation and international I&T center. To achieve this vision, it needs all sectors of the community to be united and work together. As what I just discussed with Albert just outside, innovation and technology is actually not just about rocket science. It's not just about scientific discoveries and doing all those experiments in the lab. One of the very important aspects for I&T development is about application. Yeah, and application is actually very important for the commercialization of I&T, etc. So for application, we have to have the collaboration support from all walks of life, from different industry sectors. That's actually a very important element for what contributes to the success of being an international I&T center. So indeed, I'm very happy to be able to join you all today and be happy to be invited by Thomas and Albert to join this masterclass, because it means a lot to us. So thank you very much. Thank you. And just mentioned that we need all sectors to join hands together. As we all know, the construction industry has been an instrumental driver of economic growth, which accounts for more than 4% of the GDP, and is also the fifth pillar industry in Hong Kong. Also, Hong Kong's annual construction volume is expected to grow to more than 300 billion in the next few years. Construction industry is definitely one of the key sectors in Hong Kong and will continue to be one of the very important key sectors in Hong Kong. The Hong Kong Innovation and Technology Development Blueprint outlines 4 future development directions and major strategies for Hong Kong's I&T development. Over the years, CIC has spared no effort in spearheading innovation in the industry to boost construction productivity. And also the works of CIC also matches our 4 development directions stated in the blueprint. For instance, our first direction is to enhance the I&T ecosystem and promote new industrialization, which Thomas just mentioned. On this direction, I know that the CIC actively promotes off-site construction methods such as MIC, DFMA, MIMEP, MI Infinity, and also the setup of CIC Research and Technology Development Fund to support practical application of the research, and the Construction Innovation and Technology Fund to encourage wider adoption of innovative construction methods and new technologies in the construction industry. Our second direction is to enlarge the I&T talent pool and create strong impetus for growth. On this front, the series of CIC Master Classes set a very good example to illustrate to the industry on how to enhance skill sets of industry practitioners. Those courses on MIC, Common Data Environment, and AI are able to equip our industry talents with innovative construction techniques. And our third direction is to promote digital economy development and develop Hong Kong into a smart city. Smart construction, of course, is one of the foundations of smart city. CIC has developed a construction digitalization roadmap for Hong Kong, identifying 6 high-value digital application areas to make Hong Kong to become a smart city. And our fourth direction is to proactively integrate into the overall development of the country and consolidate our role as bridge connecting the mainland and the world. The CI Expo, organized by CIC in December last year, brought advanced construction technologies from around the world to Hong Kong and provide a platform for the industry to exchange ideas and explore local and overseas business opportunities in the construction industry. So under the drive of the CIC, there is significantly increasing adoption of innovative technologies and digitalization in the industry. I hope that the construction industry can join hands with our other industries to lead Hong Kong to develop into an international I&T center. Through this masterclass, participants will learn about the latest advancement in technology and how it can be applied to construction. We believe that this masterclass will be of immense value to anyone who is interested in the future of AI for construction. And whether you are a second professional or just starting out, I'm sure that you will gain a deep understanding of AI and its potential to transform the industry. And indeed, I also want to be one of the classmates. But I think that I don't get the chance. Finally, may I express my deepest appreciation to the CIC for all its efforts in pursuing this very important initiative. And I wish you all, our CIC Master Class on AI for construction, a great success. Thank you very much.
Thank you very much, Ms. Zhang, for the speech. Thank you. Please be seated. So it is definitely the time for the construction industry to adopt AI, embrace digitalization, and join hands with other industries to lead Hong Kong to develop into an international INT center. And now let's welcome our next guest of honor, Legislative Council Member of Technology and Innovation Constituency, Honorable Duncan Chiu, to come up to the stage for the opening remarks. Let's welcome Honorable Chiu.
Thomas, Lillian, Professor Lee Jak-seung, and our fellow construction experts, friends from the industry. Good morning. I'm happy to be here. Actually, I've been invited to quite a lot of non-IT sector events in the past year. I've been trying to notify related LegCo members, colleagues, just to make sure they're not unhappy with this. But this shows the importance of technology, that actually almost every sector now have events in Hong Kong talking about the adoption of technology and how we can do better on using technology. And I know that we are talking about AI in constructions and having this master class, which is a great thing. But knowing that I have to speak before Professor Lee Jak-seung, which is experts in the area, so I just want to look better. Don't want to make me look stupid. I don't want to touch too much on AI because we have the experts later to share on you. I took some research online and look at some report. I may want to share about how are we using technology in Hong Kong at the stage of using technology in Hong Kong, not on just purely AI adoption, but also on construction in other area. So how are we adopting technology? A little study from KPMG, and as expected, on cutting-edge visionary technology and being the industry leader, we have some demonstrations in Asia. I don't have the figure on just Hong Kong, but in Asia, Asia-Pac as a whole, I think Hong Kong more likely will be in line with this study. We are more industry following and behind the curve, that account for 70–80% of the adoption of technology. And, previously, not this government, in the past, I mean, Lillian, in the past, our government is very safe, in terms of trying out new technology, other stuff, like a construction worker, you go into a site, you wear the construction hat, right? 我哋都戴頭盔做嘢, right? So always wear the construction hat before. So we are quite reluctant in trying to be the first one and adopt technology in Hong Kong. When you talk to most department in the government, we want to make sure that, it's widely adopted in the US or Europe, before we want to go for a trial test in Hong Kong. But we do have a lot of experts, like Professor Lee in Hong Kong. There's a lot more we actually can do more. Technology, some of our leading technology in China, 5G, drones, we are #1 in the world, right? Why don't we try out new projects with universities and the teams we have in Hong Kong, but always be a follower? I think that's one thing we might want to improve in future. And what area we've been using technology, and this is broadly on a global standard, drones to monitor construction sites. Are we using that a lot? I think maybe not, right, in Hong Kong. We just had a new regulations on how to use drones in Hong Kong a few months back. And, having a controller to control the drone at all time actually limits autonomous drones in many use. So whether these are things we will look to improve in future. And we have robots, but I think more robots were related to the construction area in construction industry, which many of the constructions, MICs, were not done in Hong Kong. So I don't know about the robotic part, maybe autonomous vehicle, but not on construction. Remote monitoring, I see quite a lot of examples. We've been doing that. We've been having some tried outs in these things. BIM, I think we're quite familiar with BIM. Hong Kong, we widely adopt BIM, and I was at another construction event a few months back, and I asked an architect owner. He said 30% of the staff they hire now are IT people because of they have to prepare the BIM, and now we have this open database where we have to share all major projects BIM online, which is a good thing. So I think we may not be that much behind in terms of building information modeling. Smart sensors, we're trying to have some trial cases on smart sensors as well. Radio frequency identifications, I think, yeah, these are things we've been all doing pilots in. And McKinsey's report said, construction is one of the slowest to adopt technology. I think any industry that, is highly regulated, have a few major companies dominating the market, and related to safety of people are the least modernized or are the least likely to adopt technology. So we need some trigger points. I'm actually a member of a hospital authority, which is also, healthcare is also one of the slow adopter of technology, and I'm chairman of the ITSC of hospital authority. I think for the last few years, pandemic is a trigger point. We've done a lot more pilot usage of technology in hospital and hospital management due to pandemic. Telehealth, people are quite reluctant to use it, even doctors and nurses. But due to pandemic, we have some very good tried out on telemedicines. And if people had tried that, unfortunately, if you got COVID, I think it's quite efficient, and it helps out really a big part in healthcare. And delivery of medications to home. If you try HK Go today, the app is much better than a few years back. A lot more functions you can use. So I think in terms of healthcare, a study also helped. A few years back, I think 3 years ago, we did a research that the elderly people population in Hong Kong will double in 2035, 36 to 2.5, 2.6 million. And the healthcare practitioners will not double. It might just stay at the same level. So there's no way out to provide better healthcare unless we use technology. So that also puts out the urgency to use technology in healthcare sector. So I would say we have some breakthrough the last few years. And the way to demonstrate the use of technology is by, widely used telemedicine, or also by pilot projects, which Thomas just mentioned, through some small pilot project to demonstrate the use of technology, and then before you do big employment, also shorten the time of delivery of tried out of technology. So these are things that we have to look at. I think for constructions, we already have a trigger point. We actually, unfortunately, have quite a few construction accidents last year. And I think we also have a big shortage in worker in construction. So, leveraging technology to better provide constructions and management and facility management experience, I think is the only way out. And in that, CIC plays a very crucial part. And I don't have to say more about what CIC do. I think Thomas and your team here, very well, how CIC functions and how it helps the construction industries in making better use of these. And the master class today is very important to train people on the functions and the need to use technology and to better use technology, and how it actually help construction worker, but not hindering your job. That's the same thing as the healthcare, where the doctor and the nurses are usually the most reluctant to use technology. So you have to demonstrate to them how these improve your work efficiency, but not, giving you more trouble. So I think that's one thing we have to do in CIC. And, the government policy on the use of technology, there's been quite a few touch-up. The funding to the CITF, and in the blueprint and in the Smart City 1.0 and 2.0, we touch on something about construction leveraging technology. But is that a lot? Not really, in terms of coverage in the Smart City blueprint and also our IT development blueprint just announced in December 2022. And we have some funding, but in terms of how we better use technology in constructions, I think for now it's up to the industries and CIC's members to raise. We have these big discussions just now about the light public housing at LegCo. I think I'm also going to a trip next week with another LegCo member, Junius Ho. He's going to bring us to Changsha to look at some construction projects over there, how you can build a house in relatively shorter time. But we got to see. I don't know about that, so but we got to take a look anyway. So are there other ways that we can improve? Or I think maybe we are working on the government's Smart City 3.0 blueprint, whether we can have more inclusion of technology adoption in constructions. These are things we want to see in future. And the trends in construction projects, it's not just on AI alone. I think surveying, geolocation, these are things we're trying to do with the open BIM, building the database from the government side. 5D BIM, yeah, sort of like the same thing, from geolocation to building informations. We need to have a consolidated database to actually have the work, the pre-construction works more efficiently. Digital collaboration and mobility is actually the thing that we do a lot. These are like office automation, the low-hanging fruit. I think a lot of companies have done that in Hong Kong. IoT, these include things in property management, facility management, maintenance, which I think Lee Jak-seung will be the experts to tell you a bit more on that. But we also have some restrictions in adopting some of the hardware or technologies. But I think these are all available technologies in terms of facility management. Do we still need a night shift guard? Even though we know in the newspaper what a security guard can earn like $1 million in 2 to 3 years, right? It's like a hot job people are looking for. But do we still need human there? And can we have robot to do a better job? I think so. I think you have a lot of security guard at your home where they were, especially on Wednesday, busy on horse racing, but checking instead of checking on the guests coming in. So can we have better IoT adoptions? I think definitely yes. This is the low-hanging fruit part, but not actually been done a lot in Hong Kong. Future-proof design constructions, these are like the new material, MICs and stuff. I heard from some people in the constructions area, new material is still one thing which is quite hard to adopt in Hong Kong. We have to do a lot of pilot tests, examples, and building department might be quite restrictive in using new material. It takes a long process, even though the material has been widely adopted elsewhere. So are these things we can work on to speed up the adoption of technology? These are you guys are experts. I only have the hearsay from friends. So areas that we can actually adopt technology, sort of like the same thing I just mentioned. And I think the construction part, some of these doesn't apply to Hong Kong, like the robotic in constructions. But the design and design is the thing that we actually done quite a lot of digital transformation. And operations is something that we are lacking behind. There are quite a lot of ready solutions in the market, but we haven't actually been doing that. And lastly, What IT can help, I think I don't have to mention further. I think we'll understand efficiencies, some of the jobs that repetitive job by human. I think we already proved that machines can do better in some things, in some way, and reduce death and related to constructions, construction safety. These are also things we definitely can help on. And putting forth a digitalization process, sometimes we can do more systematically, because there are things that we sort of call it a clusters. There are few technologies that we can adopt at the same time, because they sort of work in the similar directions and related to similar department in a construction process. So you can actually pilot these projects together instead of set piece. So let's say there are some constellations that people lay out that we can do automation or digital transformation projects together. And the bigger dots are actually the circle size means the popularity. So you can see that the bigger circle are actually the low-hanging fruit. Look at number 20, document management. So these are the easy stuff for people to do. I think at Hong Kong we've done that a lot, to do paperless. 16 is contract management, so same thing. These are the low-hanging fruit. So a lot of people, maybe the mentality is, okay, if I have to do digitalization, boss say we will have to do it, government say we have to do it, so let's just do the low-hanging fruit, right? The easy stuff, hire an IT consultant, pay some money and do that. But does that really solve the whole problem, or does that actually improve the overall efficiency and the time to delivery for construction? Maybe not. So I think that's the mentality we need to have. We have to approach it more systematically when we are adopting technology. How are we doing it instead of just, for the sake of doing it, but actually having better performance and efficiency in the process and really save labor in future. And I think that's all I have for today. And thanks for your time, and hopefully we have more collaboration between technology and construction. Thank you.
Thank you very much, Honorable Chiu, for the speech. Thank you. Please be seated. And today it is our honor to have invited two experts to deliver their keynote speech for us. May we now invite our first keynote speaker, who is leading AI expert and mastermind behind DJI, Professor from Department of Electronic and Computer Engineering of the Hong Kong University of Science and Technology, Professor Zhexiang Li, to give us a sharing of intelligent construction opportunities and challenges. Let's welcome Professor Li.
Dear Thomas, Lily, Duncan, and all experts and friends, good morning. It is a pleasure to share with you some of our experience involving robotics in construction. Okay. For the last 30-some years, I mostly live on Clearwater Bay HK UST campus. Okay, beautiful campus, well built, but I never know how those buildings are constructed. So about 10-some years ago, I ran a robotic incubation center in Songsanhu, Dongguan. And there, I happened to receive visitors from the industry like Wanke, Zhongjiang, Bi Guiyuan, etc. They come to me and said, Professor Li, you design and build robots. Can you help us to do some robots for this industry? I was, construction seems pretty far away from me, but nevertheless, I did take some look at the construction site and see how possibly robots can be deployed. Okay. And not until 5 years ago, we come to build our own campus, which is about 100 mu and 110,000 square meter of new campus. So we began with the design and the groundwork and then the foundation, the main structure. In the process, we see so many problems. Today you see, a batch of workers, tomorrow they were gone. And you don't know what they put inside the building, the quality, the safety, and all those. So then we, Lilian, had this, the government conceived the, Hong Kong, project. Then we made a proposal. Perhaps we can, mobilize all possible resources to, incubate project in this area. Okay, so that is, some of the learning and some of the things that we are working on. And so I would also like to, acknowledge, the support from the, Bureau of Innovation Industry. Okay. And of course, as Duncan said, the important thing is not to just build a few demonstration prototypes. We want a real deployment of those technology into the industry. So, over the last 20 or 30 some years, we've been, going from labs to startups and then backwards. So we have some experience what it will, required to, make all those happening. So I will probably spend a couple of minutes to recollect, okay, the experience and then see for the construction industry, what kind of ecosystem that we have to build in order for what we, mentioned, it will become reality, okay. So of course, I just mentioned, most of my 30 years are spent there, okay. And myself, Professor Pinko, he is an IC expert, and also Professor Ganjie, we did most of those things together as a team, okay. And I run the Automation Technology Center starting in 1992, so exactly 30 years from now. And we do all the normal things as a professor. You write papers, you teach a class, and you build your own labs, you write books, etc., etc., okay? And then this is a kind of a roadmap, how we began to taking, research from labs to, to reality. I think that happened in 1999, and Shenzhen was to, upgrade its manufacturing industry, but they don't have university support. So HKUST built a so-called IER, okay, 产学研基地 in Shenzhen. So that allowed me to understand the supply chain, the market, and how do you define product so that millions of people can utilize. So after that, of course, from a project course, students learn the real skill sets needed for startups. So DJI and, e-propulsion and many other companies. So and then until 2 years ago that we have the CRC, the Construction Robotics Center in the Science Park. So and also we try to ask ourselves, will those isolated experience, will we be able to put up a system that we can incubate in scale and in a more systematic manner, startups by students out of, fresh from campus. So we did that experiment in Songshanhu, 8 years ago. And we incubated about 60 such small groups. And today, 80% of them are still active, okay, survival rate. And, already 5 become unicorns, and 5 more probably this year or next year. So about 15%, and all of them are concentrated in 硬科技, okay? And the leading few probably valuation more than $10 billion US. And these are the names of the various companies, ranging from consumer products to industry to agriculture and now to construction. Okay. So these are the examples that started as 3-student final year project, and then perhaps a little garage in Shenzhen, and then a completely new product that we never thought we were able to do, and then began, you have a leader globally. That is the new DJI headquarters, which is already a signature building of all high tech in Shenzhen. Yeah. And of course, we are happy to see that many drones are being utilized by various process of the construction industry as well. So the lesson that we really had is aim high. That which you can turn the impossible into possible. Okay, for students, for professors, for the research group, if you are able to conceive, something that out of blue, and slowly you should be able to achieve it. So I had this particular example. 2009, I went to Mount Everest. I said, I want to see the glacier. I said, Wan Tao, can you build a drone, allow me to do that? Okay, well, Barry put together such a product, okay, and of course, we began to improve, to test, and we fly 1,000 meters out of Zimei Yako, which is 5,000 meters high. And last year, and we actually, made it. It flew from top of Mount Everest and for, a few hundred meters, allow you to see the beautiful, Everest that, you'll never be able to see before by any other means. And also, 10 or even 15 years ago, I was in Urbana-Champaign, and a farmer came to me and he asked me, I want to see my cornfield. He pulled out a very simple DJI drone and it crashed. Okay. So then I come back to get the students together. I said we should make drones available to the agricultural sector. So today you see that 1/3 of the land, farmers in China using, being serviced by the DJI drones, and also we, serving more than 66 million hectares, in China, and a little bit less in Japan, but still very substantial, because before that, all the drones were dominated by Yamaha and also those brand names. And today is 70% or 80% by DJI drones. And they make a significant impact on the industry. So those are the different consumer, smarter products by those young people. And Tianmao come to me, said that over the last few years, more than 60 new brands come from Expo Park, by those teams that we incubated. And we won lots of awards, CES, Time Innovation of the Year, etc. Okay. So they are all new, and also for the, industry technology, and that makes, the robotics for construction much easier now with all the available technology. So that is, a kind of ecosystem that we are trying to build, because the essential thing is the people, okay? So we started from university, but we're also working with K-12 and, to having people, train people, nurture people to think big, okay? So that is really the game. Okay, so with all the lessons for other things that we did, now we come back to the construction. Okay. So as Duncan just said, the construction industry is very slow in adapting new things. And we actually did a comparison between the automotive and the construction industry. One accounts for 22% of GDP, which is the 房地产 in China. The other is 8.9%. The number one and the number two industry, in China and also, I believe in other places as well. So starting from the first industrial revolution or before the industrial revolution, we are basically from the same, starting point. But, for industry 1.0, the automotive industry began to, adopt a new technology, no change, okay. And then industry 2.0, and now begin to see changes. And 3.0, automotive, lots of, robots and the things, began to be introduced, and no change again. So we ask, now we are in industry 4.0, right? You see that, Tesla, autonomous driving, Mac factory, and all those. And what will happen? Can you predict for the construction industry? Well, we see some things. BIM, prefab, MIC, and will that be enough? Can we do more? So the same slogan, thinking big. So, and we are so happy to see so many, people from different areas together, and that is a good sign, right? So, and we also did a lot of study. We, went to many of the construction sites in Hong Kong, in China, Japan, Singapore, Germany, and the US as well. Okay, so we also collect lessons that from other countries as well. Like, for example, Japan, they studied construction robotics in the 1980s, okay? And many prototypes have been developed. But after, 40 years, and they still, despite all the, promotion and also, incentives from the government, you don't see a industry of robotics for construction. Only, a few prototypes or, small units for in-house user, okay? And they mostly are still, based on, labor or imported labor as well, okay? So we have a particular example from Qingshui Jianse, which we saw that 82, 86, 89, and only 60 units are being, made for in-house use, okay? So the technology did not serve the whole industry, okay? So we ask why. One of the obvious reasons is that perhaps the scale of construction in Japan is not as big. The demand is not that strong. But in China and including Hong Kong, that is not the case, right? We have a much, much bigger market. So that solved the first problem. And also that in Japan, companies develop a solution within their own. They are not doing that for the whole industry. So that making the market even smaller. So we need to, develop a solution robots for the whole industry, okay? So that is, why we conceive the, Hong Kong Center, putting together all the players of the industry, okay? So that is how we address. So here we, when we made a proposal to the government, we said that we need an open platform involving all stakeholders, industry, university, government, and the investors. So that is the ecosystem, okay? So, so that is how the Hong Kong Center being conceived after all this study. So we have together partners from university, industry, government of the CIC, and the new technology, which are obviously, from different sectors, robotics, AI, big data, construction, product design, and we needed to address the critical needs of the industry. So where do we get the problem? So we rely on the industry experts. They come to us, their pain points, their needs, and all those. And so we will have our people who are passionate to make a change to the industry. We recruit young people from Hong Kong, from China, and they globally come to here. That they go to the construction site to understand the problem, define the problem, conceive the products, and then they develop prototypes and validate the prototypes before they spin off their companies, okay, to provide in mass. So here are some of the examples. Okay, so, and of course, prefab and modular construction are becoming increasingly popular. But still, there are lots of technology needs to make the process more efficient, more automated. So we are working also on that part as well. And despite all this MIC prefab still on site, there are lots of work to do. So the construction equipment and also training of the workers using those new tools for the new construction process. And also mention digital twins that you continuously update and also allow you to plan ahead next day operation. So here are some of the prototypes and the equipment that we developed. Many of them are being tested, validated on-site in Hong Kong, in China, and also many sites as well. We're working with CIC, we're working with China Construction in here and also in Shenzhen, elsewhere to validate. And because that LiDAR is becoming increasingly improving, okay, with the smart driving as well. So those technologies with robots together allow you to either manual operated, tele-operated, or autonomous mode. And that is an example that one of the team with a handheld or robot-held digital scanning tools that are providing accurate and data for continuous update of the beam information. Yeah. So this also during the construction of the hospitals during the COVID, and I think provided the help. Yeah. And this is another example because during various phases, especially during the renovation phase, the cranes are gone, and you still have to move a heavy material, the ALC, all those partition material from the ground floor to up there. And in the past, you use human workers, a small trolley to carry all those. So now we develop robots for moving heavy things around and also for installing the heavy panels on site. So those are under extensive testing, and also that from factory to installation, the tools needed for that. So we are collecting all the statistical data, feasibility and all those issues. And this is by, during the COVID, lots of the suppliers are over in Zhuhai, etc. People cannot go there. So how do you measure, the prefabricated components, ensure qualities meet the standard? So here, we develop the digital camera that you take pictures, you then also, collect the data and then, store data for, later use. So those are the testing field. All those prototypes are being extensively tested before they can be massively deployed. So we do that in Hong Kong, in Shenzhen, and also in Chongqing, multiple sites as well. And of course, as Thomas just mentioned, there are different processes from foundation, the structure, E&M, and the renovation, landscaping, and the deployment, and the maintenance. So I think we believe that AI, robotics, and all the new technologies are going to shape those processes and making the changes forever. Yeah. So that we hope that safer, faster, less costly, and higher efficiency construction with the deployment, development of those new tech should be on site. So those are some of the various tools being under development, and hopefully they will spin off a new industry called construction robotics, which will contribute to the 5% that Lily wants. Okay, thank you. Yeah.
Thank you, Professor Lee, for the insightful sharing. Thank you very much. So up next, to appreciate our advisory panel members, and we are now going to present the certificate today. May we now invite our presenter to the stage. I would like to invite the Undersecretary for Innovation, Technology and Industry, Ms. Lilian Chung, to come up to the stage and present the following certificate for us, please. Thank you, Professor Lee. Would you please remain at the right-hand side of the stage, please? And let's welcome Professor Jack Chang. Let's look at the front. Thank you. Thank you, gentlemen. Let's welcome Mr. Nixon Chow. Thank you. Let's welcome Mr. Paul Evans. Thank you, Mr. Evans. Thank you. And let's have Mr. Alex Ho representing Mr. Hugo Chag. Thank you, Mr. Ho. Thank you. Let's welcome Mr. Clement Ho representing Dr. Andy Lee. Thank you. Up next, let's welcome Engineer Raymond Kwok. Welcome, gentlemen. Thank you, Engineer Kwok. Let's welcome Mr. Raymond Lun. Thank you. Now I would like to invite Mr. Tim Leung. Thank you. Now I would like to invite Dr. Charleston Singh. Thank you. And we have Ms. Rosanna Wong. Thank you. Ladies, please remain on stage. I would like to invite back to the stage all our advisory panel members to the stage and take a group picture together, please. Welcome, everyone. And we would also like to extend our appreciation to the members who cannot attend our event today. Now, ladies and gentlemen, please put our hands together to Mr. Hugo Chak, Professor Martin Fisher, Dr. Andy Lee, Mr. Eric Poon, Professor Heng Lee, and Professor Wilson Liu.好，可能後排嘅嘉賓們，我哋需要向右手邊褪多2步嘅。Few step to the right for the second step of our guests. I would like to also invite the following guest to the stage, the Director of Industry Development of CIC, Mr. Robert Chan, please. All right, all the guests on stage, please look at the center front at the official camera, please. 係啦，如果喺前排嘅嘉賓嘅話咧，都可以將嗰個係啦，我哋嘅 certificate show 翻出嚟都可以。Thank you。咁嗰個我哋嘅 certificate 可以稍為面向地面多少少，咁就唔會反光啦。Thank you, thank you very much。All right, please remain on stage one more at the center. Thank you very much. Again, let's put our hands together to our advisory panel members and all the honorable guests. Please be seated. Thank you very much. Thank you. You may proceed off stage and join our audience on the floor. Thank you. Thank you very much. So after the certificate presentation, now I would like to proceed to our next keynote speaker's speech. Professor from Department of Civil and Environmental Engineering, Stanford University, Professor Martin Fisher, to be our next keynote speaker. Professor Fisher will give us his sharing of ingredients for successful AI applications in AEC to share with us through online. So now, ladies and gentlemen, please enjoy. Thank you.
Hello, I'm Martin Fischer. I'm a professor in the School of Engineering and the School of Sustainability at Stanford University, and I also lead the Center for Integrated Facility Engineering. Thank you very much for inviting me to give this lecture, and congratulations on the CIC Master Class on AI. I find that AI is really an extremely important topic today. And so this is very, very timely. Personally, I was motivated to go to graduate school at Stanford because of AI. And so now I'm very excited that we are talking about real applications, because we face many, many challenges in the architectural engineering construction industry that we need to use all the tools we can find to tackle them. And AI, as I hope I can show you, is a fantastic tool, and I hope you're convinced already of this since you're taking this class. So I've titled my talk Ingredients for Successful AI Applications in AEC, and I want to focus just on two aspects: selecting the right type of AI application and then connecting the AI application and the business purpose. Just to provide a little bit of context, one of the methods that we have developed over the last decade at CIFI is the VDC, Virtual Design and Construction. And I think many in Hong Kong and in the region have taken some of our courses. And so now we're looking to build on that experience and bring more advanced tools to our practice. So to just briefly explain what I mean by two types, or the main types of application, or the right type of application in AI, I think of that in two ways. And that also starts to connect with the business purpose we have for these applications. We can use AI applications to do what we already know how to do, because then we can do it faster, more consistently, or we can do it more frequently. Those are typically reasons for that. And I will illustrate that in a moment. And we can also use AI to do what we can actually not do, and also provide an example of that. I think as you select about your AI application, it's important to think about in which category your application falls, so that you can then choose the AI method and you understand the kind of challenge you have in developing. Because what we know how to do, in some ways, we have benchmarks, right? So we know when the application is working well. We don't really have benchmarks for things we don't know how to do, but it's still, of course, extremely useful. But let me just illustrate this with two examples. One example is a project that one of my PhD students did a few years ago, automating the scan to BIM process. So laser scanning is being used a lot, more and more wherever I go around the planet. And it's nice that we have then a point cloud that gives us where things are, but the point cloud is basically dumb. It doesn't have information about what is there. Is it a wall? Is it a desk? Is it a chair? Is it a ceiling? And so on. And often, of course, for many applications, it would be useful to have that information. We humans are very capable of transferring a point cloud to a BIM, building information model, that has this information. But it is quite time consuming, and therefore it doesn't happen for all the point clouds we make. So this is an example of where we used AI, in particular methods from computer vision and pattern recognition, to automatically create a BIM from a point cloud. So hopefully that gives you an idea what kind of applications we're talking about when I talk about allowing or enabling the computer to do what we know how to do, so that we can, for more point clouds, create a BIM and have information that's useful for other tasks in this particular case. Something we don't know how to do is illustrated by this example, or that would be impossible for people to do. Identifying the consumption patterns from 66 million consumption days, basically. I guess I should have added days in the title. So we got data from our utility from 66 million days of using electricity. And we were curious how many different patterns and what kinds of patterns there are that would explain or describe the electricity use of these households. This is entirely impossible for us to do, right? To sift through 66 million curves like shown on the slide here, and then find out, these are the 20 most common patterns, or the 200, or the 12, or whatever the number might be. But this is something a computer can do, and that becomes then very, very useful information for us, or for the utility, because with these patterns, they can then better understand the electricity use of these customers, but also they can start to predict the electricity needed when much better, which allows them to create that electricity with the environmentally most friendly methods. When we started, actually, utility said, you don't have to do this because we know that all our customers use electricity as it's shown here in this second one from the lower left. And when we actually looked at the data, we found that indeed 14% of the customers are using electricity that way. So yeah, that was an important pattern. But they had assumed that really everybody's using electricity like this, and that was obviously not the case. So sometimes it's also good to look at the data, but that can become very difficult for us to do. So this hopefully gives you an idea of the kind of applications you can use AI for things we don't know how to do. The second part I want to talk about is connecting the business value and the AI capabilities, because we have noticed, as we have worked with many companies in the context of the Center for Integrated Facility Engineering, that many AI implementations don't really succeed. And our observation is that we see a disconnect between those who ask for the AI application and those who implement it. And the disconnect seems to happen because the business people are able to articulate what AI should solve, but then there is not enough consideration what it can or will solve. And we call this the lean method for AI implementation planning, because as you will see, this is really very close to the last planner system for those of you with knowledge of lean construction. If not, don't worry about it. But for those of you with lean construction knowledge, you will see it's very much the same thought process. So to illustrate with an example, we had the pleasure to work with WSP, a large engineering company, on AI applications for highway maintenance, because this is, of course, an important topic due to life safety issues of roads, and also stringent performance requirements from the Department of Transportation. And it's very difficult for humans to detect defects quickly and consistently at the speeds at which you're driving. And some things are really difficult to see. So we were thinking if we can collect data with drones and then analyze it with AI methods, we could identify defects more quickly and fix them more quickly and have safer roads. So if we look at what different practitioners imagined on this project, they wanted sort of different things from AI. I want AI to reduce maintenance costs. I want AI to increase daily traffic capacity. I want AI to decrease rework. So if we then think about, so if we look at maintenance costs, we take practitioner one. So this is the wish list. AI should solve from a business perspective. Of course, it would be nice from a business perspective if AI helped you reduce maintenance costs. But then the question is, can AI really solve this? And that is not really possible, at least today, that AI could reduce maintenance costs directly. But it could help you with tasks that would help you reduce maintenance costs, like automated detection of cracks on highways, or predict crack growth and propagation, or predict traffic growth. Now, does it mean that AI will always solve these problems? Well, for that, you have to look at what AI will be able to do. For example, if you look at predict crack growth and propagation, we find that we found, at least in this case, that we did not have enough data to make those predictions. But that doesn't mean AI should solve all of the other problems. For that, we need to look at where is the business impact. So in this particular case, predicting the traffic growth on the highway did not offer enough business impact. So for this reason, we selected the automation of the detection of cracks on highways as the application for AI. So the lean AI method basically connects, as you saw in this example, what AI should solve, because it is good to start with this business need, this broader business need. But then we need to break that down into specific problem statement, what AI can solve. Then we need to bring the AI people, and we need to bring the AI and the business people together for this. And then the AI people need to tell us what AI will solve, what's possible with the data, labels, algorithms. And then we need to measure what did AI solve from an AI perspective, how is the AI performing, and from a business perspective, how useful is this for the business. That's the method we suggest to plan AI implementations to align the business needs and the AI application. What we see today, in contrast, right, is illustrated on the left, where we see often what AI should solve, and then an AI application is developed, but the two are not really aligned. And then when the measures come in terms of how well it's working, the business people are not happy and the AI people are not happy. And our reflection is that not enough thought went into actually planning the AI implementation by answering the questions that you see in the middle of the screen, which the lean construction practitioners among you will recognize as the questions from the last planner system. So to just take us very quickly through the steps of the framework, defining the business need, what AI should solve. Here we sometimes see that it is important to think about the bigger picture, and we see sometimes a failure to do so, and then you cannot get the attention from top management. So identifying an important problem is key here, but then also we have to be realistic, as you saw in the example, about what AI can and will do. And make it as specific and precise. Like improving project performance is not specific enough, right? How can I reduce cost, etc., not specific enough. So that we see often statements that are a little bit too vague, where we need to think a little harder to make them more specific. Then we need to translate that business need into a specific problem statement that help address the business need. Because typically the business needs are a little bit too broad for an AI application. It's really something that AI and people together need to do. And I think that's where the power will come from. So here we need to bring together people familiar with recent developments in AI, but also people that understand the operational details of the business, so that we can see where can we craft alignment, so that we can be realistic in terms of what AI will solve. Now we need to take a look at the data that the firm has or the organization, how well it's organized, and the expertise to construct an AI algorithm. We may have to set up data collection periods, of course. So here we do depend on people with experience in building AI algorithms, but again, in the context of the problem that was defined in the previous step. And then we need to define AI metrics and business metrics and create a link between them, so that we can assess whether we were successful, and we can keep learning, because in our experience, in most cases, we don't necessarily get it right the first time, and we need to keep iterating. But again, this framework helps you iterate to create a successful AI implementation. So the takeaways from this talk are for you, hopefully, to think about the type of AI application. Are you doing the AI application to do more of what you know how to do, or do you want to do something new that you don't actually know how to do yet? And then connecting the business need and the AI implementation with these questions: what AI should solve, what it can solve, what it will solve, and then what did it solve, so that you can become an AI-enabled organization. Because sometimes people ask me, they say, Martin, will AI take away my job, etc.? I don't think so, at least not in the near future. Rather, I would say somebody who uses the AI well will take away your job. That's the more likely scenario. And it was really in the spirit that I made these comments, to allow you to become one of the practitioners that uses AI well, and then through that derives business value, whether that's on the cost side or whether that's on the value side, being able to offer your customers more value, tackle more problems more rapidly, more predictably, because these are benefits that I see we can get from AI. So thank you for listening to my talk on ingredients for successful AI applications in AEC.
Thank you, Professor Fischer, for the generous sharing and your insight on AI. So now, to round up our event, I would like to invite Engineer Albert Chang to come up to the stage for the closing remarks. Ladies and gentlemen, let's welcome Engineer Chang.
Professor Li Jiaxiang, Director Karis, Chairman Thomas, also the Professor Martin on the line. Thank you, distinguished guests, ladies and gentlemen. Thank you very much for attending this launching ceremony. I'm not going to repeat the beauties and the need of the AI for the construction industry. Indeed, I would like to appeal to all the industry practitioners in Hong Kong and also overseas, elsewhere in the world, that
really, I mean, application of technology is a need for construction industry. I mean, last week we have CIC has published our manpower forecast for Hong Kong construction industry. And indeed, even this year, we are talking about lacking of more than 10,000 of construction workers, thousands of professionals, and also technicians. And in Hong Kong society, and also similar modern society in the world, I mean, we are lack of youngsters joining our construction industry. Our birth rate is much lower than before. So we are talking about, I mean, if we don't have construction technology, we really can't meet the workload required in the construction industry. So technology is a must, and is the only solutions to meet such a demand. I mean, we can see that the application of AI is wide and spread over everywhere in our daily works. I mean, from the planning stage, I mean, we can also adopt AI in our generative design, our parametric design, etc. And then in the construction stage, we should adopt AI in helping us doing all sorts of construction activity need, such as surveying, such as monitoring, inspection, etc., and etc., quality control. And then in the operation stage, we can adopt AI in our, let's say, I mean, the maintenance and inspection of our facilities. And also, for instance, in inspections of the quality of work before the developer hand over the building unit to our buyers. I mean, there's a lot of argument in the past that are talking about whether the quality of works is up to the buyer's standard, I mean, to the contract specifications. So this kind of area is a good application of artificial intelligence. Now, I'm going to repeat, as I said, I mean, the need of the AI and the beauty of the AI in our daily works. But in here, I would like to make a few appeals. Appeal first is that, just said that by Professor Lee Jiaxiang and also Professor Martin, that for application for AI, we need data. And for data, we need testing bed. So I would like to make an appeal to all our practitioners, main contractors, clients in Hong Kong construction industry. Please make use of the project to allow those, I mean, the AI startup to use our project as a testing bed and then to collect data in order to help them to improve their product and also help them to scale up, I mean, their product for a wider application of the product in the industry. So this is a very important. And also, I mean, CIC will continue our effort to, I mean, promote technology. So in the coming years, we still will launch a lot of this kind of master class in various disciplines, in MIC, in construction digital environment, in safety, in temporary work, etc., and etc. And not only the launching of master class, we're going to arrange a lot of site visits. For instance, I'm talking to Professor Lee Jiaxiang. In the next month, we are going to have a visit to the Chongqing, I mean, AI laboratory. So we'll let you know, and then we'll bring a big team to go there and learn AI. And last but not least, we are also, I mean, recently I have ventured overseas to learn a lot of this kind of construction technology startup. One of the places that I went to is Israel. They really have a lot of good cases there. So we are now going to have a webinar next week to invite, I mean, Israel startup to talk about their products. It's a very good webinar. You're going to have English and Cantonese bilingual. There's a QR code there. Please scan the QR code, make a registrations, and learn something from the webinar. Thank you very much.
Thank you very much, Engineer Chang. Thank you. Please be seated. We've come a long way to promote AI in construction, which would like to encourage the large adoption and implementation of advanced construction technologies in Hong Kong to achieve our target, smart construction. So once again, thank you very much for our participants and of course our online audience for joining our kickoff ceremony today. So the module 1 of the masterclass is about to begin. I would like to invite all the guests, please proceed to the corridor and to take photo at the corridor backdrop. The class will be started at 11:05 a.m. So with all the students, please come back at 11:05. We have to set up the classroom first. So thank you once again for your presence today. Have a wonderful day and we look forward to seeing everybody in our future events. Thank you. Goodbye.